So in this class, you learn the very first thing you learn is capacitors. In a capacitor is drawn here. This blue square thing that you see is a capacitor. A capacitor is defined as something that is like a battery, but a very lousy one because it cannot hold a charge for a very long time. So if you power something from capacitor, there's a very good chance that whatever you're powering will be powered for only very brief amount of time as compared to a battery. So the very first circuit you see right here on your screen is this circuit where you have a special kind of switch where you can turn the switch on either this way, up position, or this way, that is the down position. So if the switch is on the up position here, the way it is shown on the screen right now, the capacitor is being charged by the battery because the current goes here through the capacitor, goes back into to the batteries, and the capacitor is charged. Once the capacitor is charged, you can turn the switch back, not back, turn the switch to the other position. So when you do that, the battery now gets disconnected from the circuit, because if you do that, then the circuit is this, and the battery is excluded from the circuit. If you don't believe me, go ahead and make that circuit and see what happens when you do that change in switch. So when you do that, the second time when the second time the battery gets eliminated, it gets separated from the circuit, and what that enables the capacitor to do is it enables the capacitor to act as its own battery, and now you have got this battery or capacitor connected to this light bulb, and therefore the light bulb uh, is supplied the current by this blue piece, which is the capacitor, and it only happens for a very brief amount of time. So if you have done this experiment, you know that when you change the switch to the down position, the capacitor is working on the bulb, and the bulb glows for a very brief amount of time. The very next thing you see is a formula, which is power equals to voltage times time, not not time. Power equals to voltage times current. And the way you can use this formula is if you have a circuit that is given below, and it's a very simple circuit I have drawn here. A 4-volt battery is powering this light bulb, and a 2 ampere current is in the circuit. Okay, so if that is the case, then the power is voltage, that is 4 times 2, that is 8 watts, or 8 W. W means watts. So as you can see, if you multiply the voltage times the current, you get power. Now, interestingly enough, if you remember, the 8-watt power is supplied by the battery, because across the battery, the voltage difference is 4 volt, and the current that is going through the battery is also 2 ampere. Okay. And also the power that is received by the bulb is also 8 watt, because through bulb the current is 2 amperes, and if you measure the voltage difference, it will be 4 volts. Remember, I don't have to measure it, because I know a 4-volt battery is giving this voltage to only one bulb. So the bulb will also get the whole amount of voltage given by the battery, and that is 4 volts. So power supplied by the voltage, power supplied by the battery is 8 watts, and power received by the bulb is also 8 watt. Now the second formula you C is power equals to energy times over time, or energy is equals to power times time. So imagine this light bulb that you see in the circuit. eh, It's it has been on for 1 hour. Okay, so if you want to find out what is the energy consumption, if this is on for 1 hour, the energy consumption is power, that is 8 watts times 1 hour, and that will be 8 watts an hour. Okay, that's how you do it. If the time is given in seconds, and let's say it was on for 30 seconds, then the energy is power times time, and that is going to be 8 watts times 30 seconds. Let me choose a nicer number so that I can multiply this in my head. 8 times, let's say it was on for 10 seconds, so the answer is energy is 80 watt second. So that's how you use this formula. The next thing you can, like next type of question that you can see is, if a 100-watt bulb is used for 5 hours a day and your electricity rate is 12 cents per hour or $0.12 per kilowatt hour, how much would it cost to run it for a month? So this associates uh, the kilowatt hour or kilo or watt hour or watt second with dollar amount that you would need to pay depending on what rate you get. So in this case, we have a bulb that is on for 5 hours a day, and um, it is going to, let's say it runs for a month. Okay, so for 5 hours a day, 100-watt bulb. So let me calculate how many watt hour is that in one day. So watt hour in one day is going to be 5, because that's the number of hours, times 100. It's going to be 500, not 1000, watt hour. Okay. Now to convert watt hour, so the thing is, like, we need to convert this watt hour to kilowatt hour, because that is what we know. Like that is, like, we know it's gonna be $0.12 per kilowatt hour. So eventually you will be multiplying 0.12 by however many kilowatt hour we have. So it is really nice if we right now convert this watt hour to kilowatt hour. So all you need to know is 1 kilowatt is equal to 1,000 watts. So 500 watt hour, or like if you know 1 kilowatt is equals to 1,000 watt, you know that 1 kilowatt hour is 1,000 kilowatt hour. So in that case, what will be 500 watt hour? Well, 500 watt hours is equal to 500 over 1,000. That gives you 0.5 kilowatt hour. Now the next thing is, this is per day. So per day it is going to be 0.5 kilowatt hour. But for a month, and then a month has 30 days, we'll have to multiply this month. For a month, we'll have to multiply this by 30 to get the total kilowatt hour number, and that will be 15 kilowatt hour. So now we know if the bulb is being used for a month, it's gonna draw 15 kilowatt hour energy. Now the energy cost is 12 cents per kilowatt hour. So if it is 15 kilowatt hour total amount, will be rate times kilowatt hour, and it is 15 kilowatt hour, and it is 0.12, that's dollar amount. So if you multiply those two numbers, you will see that this will be equal to $1.80 per month. So the answer is, if this bulb is being used 5 hours a day for a month and at a rate of $0.12 an hour, you will have to pay $1.80